The question we are solving now belongs to test series 10. It is of control system subject. In specific, it belongs to basics of control systems. As per the question, the open loop transfer function of a control system is given as 25 divided by s multiplied by s plus 3. We need if STH gives the sensitivity of the overall transfer function with respect to h of s. We need to find the maximum possible magnitude of this sensitivity. We know that the sensitivity of overall transfer function with respect to h of s is given as minus g of s multiplied by h of s divided by 1 plus g of s multiplied by h of s. And this upon simplification becomes minus 25 divided by s square plus 3s plus 25. Upon substituting s is equal to j omega, we see that the sensitivity becomes minus 25 divided by 25 minus omega square plus 3j omega, and the magnitude of the same can be written as s abs of STH is equal to 25 divided by square root of 25 minus omega square whole square plus 9 omega square. Let us take b of omega is equal to 25 minus omega square whole square plus 9 omega square. When b of omega is minimum, square root of b of omega is minimum, hence magnitude of STH will be maximum. Hence, let us find the omega at which b of omega is minimum. For finding the same, let us equate dB by d omega to 0. Upon doing the same, we see that 2 times 25 minus omega square multiplied by minus 2 omega plus 18 omega is equal to 0. So from this equation, we see that upon cancelling the omega, this is based on the assumption that the angular frequency omega is not equal to 0 radians per second. We see that this equation can further be simplified as 4 omega square minus 4 omega square minus 82 is equal to 0, and upon simplifying the same, we see that omega is equal to square root of 41 by 2 radians per second. Now let us evaluate d square b by d omega square at this omega, and upon finding the same, we see that d square b by d omega square is greater than 0 at omega equal to root 41 by 2 radians per second. From this we can say that at omega equal to square root of 41 by 2 radians per second, b of omega is minimum, hence the sensitivity is maximum. So from this we see that abs of STH max happens at square root of 41 by 2 radians per second, and this can be written as 25 divided by square root of 25 minus 41 by 2 whole square plus 9 multiplied by 41 by 2, and upon simplifying the same, we see that this can be written as 50 divided by square root of 819. From this we can say that the magnitude of the sensitivity has a maximum value of 50 by square root of 819, hence the correct option is A.